ever feel like AI is taking over the world?
Mm.
Okay, maybe not taking over.
Yeah.
But it's everywhere.
It really is.
And I'm not just talking about those like eerily accurate shopping recommendations you get online.
Yeah.
Although those are kind of freaky, right?
I get you.
Like, how do they know I needed that? But we're talking self-drives cars, disease prediction, stuff that used to be pure science fiction.
Right. It's like we're living in the future.
We are. But here's the thing. How much do we really understand about how it all works? What makes AI tick?
That's the question, isn't it? Most of us, we interact with AI on a very surface level.
Totally.
We see the cool applications, we see those impressive results.
Right.
But the inner workings, those nuts and bolts of how it actually functions,
Yeah.
that often remains a mystery.
A total mystery. And that is what we are diving deep into today.
Like,
the nitty-gritty, the nuts and bolts of AI.
let's do it.
And get this, we're doing it with a twist.
Ooh, I like twists.
Our source material. A Spanish language textbook called, get this, Inteligencia Artificial Avanzada.
Wow, fancy. My Spanish is a little rusty, I'll be honest.
Don't worry, mine too. We're here to translate. We're going to unpack all the good stuff.
Sounds good.
All the fascinating insights that this book has to offer.
I'm ready.
So don't worry, your Spanish doesn't have to be that good. We got you.
Because you'd be surprised, actually, how universal these core concepts of AI really are.
That's so true.
So language aside, this textbook,
Yeah.
it gives us a really unique window into these fundamental principles, how AI learns and processes information.
Okay, so first mind-blowing concept this Spanish text throws at us. A comparison between our brains and computers.
Interesting.
They delve into this whole neurons versus transistors thing.
The building blocks.
Yes.
Right, of both systems. It's a fundamental question that comes up a lot in AI research. Can we truly replicate the complexity of the human brain in silicon?
Right. Are we trying to rebuild our brains?
Well, in a way, yeah. And the book uses this comparison to really highlight that. Like you said, your neurons, they're firing away in your brain.
They're doing their thing.
They're like those transistors in a computer processing information.
Okay, so that's kind of the first layer. Like, what are the pieces?
Exactly.
But then it gets even more interesting because the textbook dives into this whole idea of plasticity, right?
Yes. Love this.
How our brains are constantly rewiring themselves as we learn new things.
Right. It's not static.
It's always changing.
Constantly adapting.
And this, it turns out, is like a key concept that AI is trying to replicate.
It's essential because that's what makes learning possible.
Exactly.
Every time you learn a new skill, your brain adapts. It actually physically changes its structure.
Whoa, really?
It's incredible. And that's what makes AI research so fascinating.
So we're not just talking metaphorically, like the code is changing.
It's deeper than that, right?
Mm-hmm.
Scientists are trying to mimic this process in AI systems.
Wow.
To allow them to learn and adapt just like our brains do.
So that's where we get machine learning coming in.
Exactly.
It's not just about pre-programmed instructions anymore. It's about this AI figuring stuff out on its own.
Right. Think about it this way. Traditional programming is like giving someone a really detailed recipe.
Okay.
Step-by-step instructions.
Yeah.
Machine learning, on the other hand, it's more like letting a chef loose in the kitchen.
Ooh, I like where this is going.
With a pantry full of ingredients.
Okay.
We provide the data, we provide those algorithms, and then the AI experiments.
It gets to play.
It learns, it refines its own recipes, if you will, based on the outcomes.
Okay, that's a tasty analogy. I like that.
Yeah.
But how does that actually play out, though, in the real world?
Yeah.
Like, what's the significance of AI being able to kind of mimic this plasticity that our brains have?
So imagine AI that can analyze complex medical images and detect diseases in their earliest stages,
Okay.
even before they might be visible to the human eye. Or imagine educational software that can adapt to a student's individual learning style.
Wow.
Providing a truly personalized learning experience.
That's incredible.
That's the promise of AI that can learn and adapt, just like the human brain.
That's incredible. Okay, so AI is learning like us, adapting like us, maybe even thinking like us. Kind of. But there's this other big piece of the puzzle, right? All that data.
Oh, yeah.
We're practically drowning in data these days.
Drowning's the right word.
And AI has to somehow make sense of it all.
Well, you've hit on a really crucial point. This is what we call the data deluge.
Ooh, I like that.
It's not just a lot of data, it's this overwhelming flood.
It's like trying to drink from a fire hydrant, I imagine.
It really is, and that's a fundamental challenge for AI. Think about it, we're generating just unimaginable amounts of data every single day. Social media posts, financial transactions, sensor readings from who knows how many devices. The list just goes on and on.
So how can AI possibly find anything useful in all of that, in that mess?
That is where dimensionality reduction comes into play. It's one of those concepts that sounds super complicated, but it's actually quite elegant.
Okay, I'm intrigued. Unpack that for me.
Imagine you're trying to understand the essence of, say, a really complex painting.
Okay.
You could analyze every single brushstroke, every color variation, but would that really give you the full picture?
You might get lost in the details, I guess.
Exactly. Dimensionality reduction is about stepping back, seeing the bigger picture. Instead of getting bogged down in every single data point, we try to identify the most important patterns, the underlying structure that captures the essence of what that data represents.
So finding the signal in the noise.
Precisely. Your textbook uses a really interesting example,
Okay.
talking about analyzing data from thousands of soccer players, goals scored, assists, passes completed, all of that. Instead of just looking at each of those stats in isolation, AI can use a technique like principal component analysis, or PCA,
Right.
to find these hidden relationships between all those different data points.
So instead of just saying a jumble of numbers, PCA helps us understand what those numbers actually mean about that player's, skill set, their style.
Exactly. It's about extracting meaningful insights from complex data. And it's not just about soccer, this concept, this dimensionality reduction. It has huge EE implications across all sorts of different fields.
Like what? Give me some examples. So the book mentioned marketing and medical diagnoses. Give me the examples. I'm ready.
Okay, so imagine you're a marketer and you're trying to understand your customer base.
Okay.
You've got mountains of data about their browsing habits, purchase history, demographics, you name it.
Right.
Dimensionality reduction can help you identify these distinct groups of customers with similar behaviors and preferences.
Oh, that's cool. So instead of just blasting everyone with the same generic ads,
Exactly.
you could actually tailor those marketing campaigns to those specific groups, make them way more effective.
Precisely. Or in medicine, imagine doctors using AI to analyze patient data symptoms, medical history, genetic information. Dimensionality reduction can help uncover these hidden patterns and correlations that might not be obvious just from looking at all that data.
Wow. So it's like AI is giving those doctors this superpower,
Yeah.
helping them see connections they might otherwise miss.
That's a great way to put it, because it can be really powerful, this dimensionality reduction. And actually, speaking of powerful, there's this part in the book. Remember how we always talk about those humans share 99% of the same DNA fun facts?
Yeah.
Well, PCA can do something very similar, but with faces.
Wait, what? Tell me more.
It's called eigenfaces. It sounds very sci-fi, but it's a real thing.
Okay, I'm listening.
So we know PCA finds those important patterns in data, right?
Right.
But how do you apply that to something as complex as the human face? Well, imagine you feed an AI system thousands upon thousands of images of faces. PCA can then identify the most common features, those building blocks of what makes a face recognizable. These are what we call eigenfaces.
So each eigenface is like a blueprint for a specific facial characteristic.
Yes, exactly.
One for eye shape, one for nose size, and so on.
You got it. And here's the incredible part. By combining these eigenfaces in different ways, you can actually reconstruct any face in that data set.
Wait, so it's like having this set of Lego bricks, but instead of building a castle, you're building a face.
That's a great analogy.
That's wild. But what's the practical application of that? What good are all these eigenfaces?
Remember how we talked about AI and security cameras?
Yeah.
Well, eigenfaces take that to a whole new level.
Beyond just detecting motion.
Exactly. Security systems can use eigenfaces to actually recognize individuals, even in crowded areas or with partially obscured views.
It's like having this super-powered security guard who can identify anyone in an instant.
It's powerful stuff, although, of course, we do have to be mindful of the ethical implications.
Right. Facial recognition can be kind of a slippery slope.
Very true. But for now, let's just appreciate the technical marvel of PCA and how it can be used to analyze and understand something as complex as the human face.
It's pretty amazing. From mimicking how our brains learn to unlocking the secrets of facial recognition, this AI deep dive is blowing my mind.
Right? It's a wild ride.
But this is just the tip of the iceberg, isn't it?
Oh, there's so much more to explore.
Because we've seen AI recognize patterns, but what about making decisions?
Now you're getting to the really interesting stuff. Because AI isn't just about analyzing data, it's about using that analysis to make choices, often very complex ones.
Okay, so how does it do that? Where do we even begin to unpack that?
Well, the textbook highlights a really fascinating problem: server optimization.
Okay.
Imagine you're trying to distribute workloads across an entire network of servers to make sure that websites and apps are running smoothly and quickly.
Okay, so we're back to those server farms with all the blinking lights.
Exactly. It gets incredibly complex, especially when you factor in things like fluctuating demand. That's where the ant colony optimization algorithm comes in.
And colony optimization. Now you're just messing with me.
I promise it's a real thing, and it's pretty amazing.
Speaking of AI making decisions,
Mm.
this next concept from the textbook really blew my mind. It's like something straight out of a nature documentary.
Let me guess, are we talking about ants again?
You got it.
Mm.
It turns out those tiny creatures have a lot to teach us about solving really complex problems, at least when it comes to AI.
It's true. Your source material highlights a fascinating example: the challenge of server optimization. Imagine you're running a huge website or a popular app.
Okay.
You've got this whole network of servers working behind the scenes to handle all the traffic and data requests.
Okay, so picture a giant server farm, all those blinking lights and whirring fans. Not exactly the Serengeti, but I'm with you.
Well, the goal is to distribute that workload across all those servers in the most efficient way possible.
Right.
We want to make sure websites load quickly, apps run smoothly, nobody's left waiting around for things to happen.
Makes sense.
But finding the absolute best way to do that, especially with like fluctuating demand, it gets incredibly challenging. That's where this ant colony optimization algorithm comes in.
And colony optimization. Okay, now you're just messing with me.
I promise you, it's a real thing, and it's actually pretty amazing.
Okay, I'm listening.
Think of it this way. Imagine virtual ants crawling around your server network.
Virtual ants. Okay.
Each ant represents a possible solution to this server optimization puzzle. As they explore different ways of distributing that workload, they leave behind these virtual pheromone trails.
Okay, so the more ants that find a particular solution effective, meaning it keeps those servers humming along smoothly, the stronger that virtual pheromone trail becomes.
Exactly. It's like a digital version of those ant trails you see leading to a tasty crumb. The more ants follow a path, the more appealing that path becomes to other ants.
And over time, this virtual pheromone system helps the algorithm zero in on those most optimal solutions for distributing the workload across the servers.
Precisely. It's like crowdsourcing, but with virtual ants instead of humans.
That's so cool. So by mimicking the way ants communicate and collaborate, AI can solve these really complex optimization problems. It's like finding these elegant solutions hidden in plain sight.
Exactly. And this ant-inspired approach, it has implications far beyond just server farms. Think about logistics companies optimizing delivery routes to get packages to your doorstep faster, or city planners using AI to analyze traffic patterns and reduce congestion.
Oh, wow.
It's all about finding these smart, efficient solutions by taking cues from nature's playbook.
This entire deep dive has been one mind-blowing revelation after another. But as we start to wrap things up here, our Spanish textbook, it leaves us with a final, thought-provoking concept. Ready for a bit of a brain teaser?
Hit me with it.
Okay, so we've seen how AI can learn like us, adapt like us, and even make decisions inspired by the natural world. But the book hints at a potential limitation, something called the curse of dimensionality.
Ah, yes, the curse of dimensionality. It's a concept that highlights a really fundamental challenge in the world of AI, this trade-off between complexity and data.
So as AI systems become more sophisticated, their hunger for data grows exponentially. It's like saying, with great power comes a great need for even more data.
Exactly. Think about it. The more complex the task you want AI to handle, the more data it needs to learn those patterns, to make accurate predictions, to find those optimal solutions.
Right.
And as those tasks become more and more complex, the amount of data required, it can become absolutely massive.
So could this insatiable need for data eventually become a limiting factor for AI? Will we reach a point where we simply don't have enough data to satisfy AI's ever-growing appetite?
That's the question that researchers are grappling with right now. It's a bit of a balancing act. On the one hand, we want to push the boundaries of what AI can do to tackle bigger and more complex problems. But on the other hand, we need to be mindful, right? We need to make sure we're being responsible with data collection and usage.
Right, because where will we get all this data?
Yeah.
And what are the ethical implications of gathering and analyzing these massive, massive data sets?
Good question.
It's like we're standing at the edge of this uncharted territory. The possibilities of AI seem almost limitless. But so do the questions. So do the challenges that we need to address.
It's true, and I think that's what makes this field so fascinating.
So to our listeners, we leave you with this final thought. The world of AI, it's dynamic, it's complex, and it's constantly evolving.
Always change.
So stay curious, keep asking those tough questions, and never stop exploring this fascinating intersection of technology and human ingenuity.
Well said. Until next time, everyone, happy deep diving.